Okay, this is logarithms, and just a quick review of them. Log is converting log base b of x equals y. Remember, logarithms are inverses of exponentials. Converts to the equivalent b to the y equals x. So this asks me to evaluate these without a calculator. I'm just going to say equals x on all of these. Um, but and I will convert them all to exponential form. 3 to the x equals 1/9. That's like 1 over 3 squared, which is 3 to the negative 2. 4 to the x equals 64. That's x equals 3, so 4 to the third. So my answer here, instead of an x, that equals, do those two, negative 2 and 4. This last one becomes a to the x equals a to the m. Well, x equals m. There's a little interesting property here about logarithms. If it's log base a of a to the power of, those just cancel out and you get what's left as the exponent. And that's a real nice shortcut rule that's probably important to know how to use. Okay, evaluate each of the following without a calculator. Um, so here we have, again, we could go x. A to the x equals 1. Well, what power equals 1? That's always the 0 power. So log any base of 1 equals 0. A to the log a of m, so again set this equal to x, and we'll do log base a of x equals the exponent, which happens to be another logarithm, log a to the m. So base to the opposite side, or log of the base of the exponent of the other side equals that. So remember, log base b of x equals y. I was in the b to the y equals x. So my exponent goes to the opposite side. Clearly, we can see x here equals m. Another property here, log base a of a to any power, or a to the log base a, again, just cancels. Those are inverse operations. This one, a to the x equals a, that would mean x equals 1. That's 1. This is m. E to the m, same power property up here. ln is log base e, so that's simply m. Inverse operations, and those make your life a little easier. All of those little properties right there. Very helpful. Okay, now we're going to talk about the laws of logarithms in the next section. And the laws of logarithms are something you've been learning for a few years. Look kind of like this. They're on the front page of the packet I gave you. I'm not sure if they're in the exam packet. But multiplication equals addition when you separate them, division, subtraction, and the exponent comes to the front. These are your three laws of logarithms. You should have seen them plenty of times by now. So let's use them. Write this as a single logarithm, which will then require us to simplify it. So I have an addition. So that means multiplication. This is over 1. I can cross reduce. With my x's go away. One of my y's goes away. And my final answer becomes log 7 of y. Okay, here's a little information. Log base d of 5 equals 8. Log base d of 10 equals 11. Find log base d of 2. Okay, log base d of 2 would equal log d of 10 divided by 5, which is log d of 10. So I'm looking at my insides, going, how do I get a 2? 10, that's 10 divided by 5. So it's log d of 10 divided by log d of 5, using my laws of logarithms. And I'm told the first one, that's 10, 11 minus 8, this is 3. So I had to look for a way to make what was given in the logarithms 2. So that's 10 divided by 5. And then use my laws of logarithms. And then I substitute the answers that it tells me in the problem. Okay, example 3. Given that log base a is 2, since these logs do not have a written base, they are base 10. Log b is -6, log c is 3. Find the value that's given. So find the value of log of a squared c over log b. So the top being multiplication means it's addition, and the bottom is subtraction with the division. I can do that all in one step. That is perfectly fine. Now I'm going to use my exponent law to simplify this some more. The cube root is the 1/3 power, so I'll bring it to the front as a 1/3 power. Now I can just substitute the values they've given me. This log a is 2. This is I wrote that out wrong. I jumped ahead. Log c is 3. And log b is -6. 4 plus 3, -1/3 times -6 is +2, equals 9. Okay, a couple more examples, and this one will be done. It says rewrite this as a single logarithm. The key to rewriting as a single logarithm is I got to bring these numbers in front up first. So I got ln a plus ln b cubed minus ln c to the 12th. Addition, when I combine them into one, means multiplication, and I can just do it in the same step. Subtraction means division. So anything with a minus is going to the denominator. Anything with a positive is going to the numerator. And there's my single logarithm. That's it for 1.9.